In this video, we are going to do these 3 questions from the chapter circle, including 2 MCQ. And these are based on these 3 properties related to tangents and chords of a circle. So let's start with the first question. In this question from the chapter circle, it says from an external point P, tangents PA and PB are drawn to the circle with center O. So let's begin with making a circle first. So I made a circle and there are 2 tangents, and the tangents named are PA and PB are the 2 tangents drawn. So with an external point as P. So if I take, so this is as say one tangent, all right, and the other is from the same point, right? It has to be same exterior point P. So it's named PA, where A and B are the points of contact. As I read further, it says if CD is a tangent to the circle at point E, so there is another tangent drawn over here, and the tangent named is CD, right? So I have to make another tangent. Let's say this being another tangent over here, and what is the point of contact? It's not mentioned, but it's named CD. CD is the tangent, so this point is C, and this being D. And let's say I take this point of contact as M, and O being the center of the circle. What we have to find out before that, we can see length of PA is given as 14. So what is 14 over here? I should show you. This is 14, right? From here to here. And so is P to B. This length is given as 14 unit or 14 centimeter, in fact, 14 centimeter. Then what we have to find out is the perimeter of this triangle PCD. So we need to get the perimeter over here, and the triangle over here is this. We have to get the perimeter of this triangle. Now from here, what you can see that the perimeter of this triangle, let's say I use just letter P over here for perimeter. It should be what? The sum of 3 sides, that is PC plus CD plus PD. And as I said, this question is based on tangent from same exterior points. So we are going to use this concept. So we are going to use this, that the tangent from same exterior point are equals. So what you can see in the first go, can we write this length PA and PB? You can see that they are tangent from the same exterior point. So we can write they are equal. That is PA is equal to PB. But you can see further that even AC and CM, right? They are also tangent from same exterior point. So I can write the length CA is equal to CM. And there is one more that you can see here, that is DM is equal to DB. For the same reason, DM is equal to DB. And these are from the property that tangent from same exterior points are equal, right? Once we have obtained this information, what I'm going to do is to break these sides in terms of the tangents. Let's begin with the first one. We have the length PC over here. Check in the figure what we can write PC as. Can we write PC as PA minus AC? Similarly, the length CD, what you can write here CD as, CDs can be broken as CM plus DM. They are not equal. This is CM plus DM. And we are left with one more side, that is PD over here. I check for the length PD. PD can be written as what? PB. As I said, we are splitting in terms of the tangents. PD minus DM. Sorry, PD minus BD. That's PB minus BD should give you the length PD. Now what you can see from here, tangent from same exterior point, we know that PA length and PB are, so I can replace PA. The length of PA is given as how much? 14. So I can write 14 over here. Now check for AC. AC and CM are equal. So we can cancel AC and CM. And DM and BD are equal. DM and BD are equal. So they get cancelled. We are left with BD. And what is the length of BD? BD is 14. So it should come as how much? 28 centimeter. This would be the answer for this question. In the next question, it says if the angles between the tangents drawn from an external point P to a circle of radius A, right? This is radius A over here. and the center O is 60 degree. Then find the length of OP. So what we are going to do is the same way. We are going to make a circle first, and we are going to draw two tangents from an external point, exterior point. Not the exterior point is named as what? It's P. Now let's say this is P, and I'm going to name this as A and B as the point of contact. And its center is given as O, and we are given the length of the radius. Let's say if I join this, so one of them only, and the radius is not R over A, it's mentioned A, so we should write it as A only. And this angle between the tangent is given, this angle is given as how much? 60 degree. This is 60 degree. What we have to find is the length of OP. So let's join OP. If I join O with P, this is the length we have to find out. Now we know that radius is perpendicular to the tangent at the point of contact. So we are going to use the concept of trigonometry, but before that you should know that the line joining the center to the exterior point of the tangent is perpendicular bisector of this angle between the tangent. So let me write down what we have, this property, that is the line joining the exterior point of the tangents to the center is the bisector of the angle between the tangents. So can I say this is 30 each? Right. Now you need to consider this triangle. In this triangle, what you can observe that it's a right angle triangle, and I need a relation between this side, which is what? Which is actually a perpendicular, and this side, which is the hypotenuse. So we can apply sine. So sine 30 is what? Perpendicular, which is AO, over hypotenuse, which is OP. So sine 30 value is half, and OA length is A, and this is OP. So therefore we can write by cross multiplication, OP should come as 2 times A, right? Now we have to find its length, but as you know, this letter A, or the very whatever the arbitrary constant A is introduced by the question only. So you'll be leaving the answer here only, right? In terms of A only. That's how we will do this question. Now in this question, it says two concentric circles of radii A and B, where A is greater than B. So let's first make two circles, and we are going to take two concentric circles over here. They are what? Circles with the same center and different radii. Now further it says the length of the chord of the larger circle which touches the other circle. So we are going to draw a chord for the larger circle, but that should touch the inner circle. Let's say I name this chord as AB, and this being the point of contact, let's say I took this as M. Well, O is the center of the circle over here. And if I join this point with M, this O, as I said, is the center of the circle. So we have OM as the radii for the inner circle, and let's join OA as the radii for the other circle. What you can see, it's given that A being bigger than A is greater than B. So clearly A has to be this and B is this. Now, further we need to figure out that which relation is correct line. Let me once again tell you that what we have to find out is the length of this chord, right? AB, and in this case, the length of AB will be what? So we are going to apply these two property. Number one, that is perpendicular drawn from the center bisects the chord, and radius is perpendicular to the tangent at the point of contact. So let's first figure out the inner circle. What you can see in the inner circle. In the inner circle, we have AM is acting as what? As a chord. You can figure out that AM is a chord over here, and OM is what? A radius. So what we know that a radius is perpendicular to the tangent at the point of contact. So using this property, what I can say that here OM is perpendicular to AB. Now let's figure out the other property for the uh, outer circle. What is AB here? AB is what? A chord, right? And what we have proved that OM is perpendicular to AB. So we know that perpendicular drawn from the center bisects the chord. So using this property, we can say that over here, we can say that length of AM is equal to BM. Now we are going to apply a Pythagoras theorem in this triangle? Well, triangle is this. We are talking about this triangle. What we know that the square of the hypotenuse, clearly it is AO is the hypotenuse, is equal to the sum of the squares of the other two sides. So it's OM square plus AM square. OA is how much? A, so it's A square. OM is what? B, so it's B square plus AM square. Now, if I transpose this B to the left-hand side, what it results to give you, this will give you what? A square minus B square should be equal to AM square. Now figure out if I transpose this square to the left-hand side, it's going to be under root, right? So we can say that the length of this AM should be how much? Length of this AM should be under root A square minus B square. But then we have to find the length of this whole chord, not just AM. And we can see this is AM and BM are equal over here. So we can say that the length of AB will be twice of AM. So this would be 2 times under root A square minus B square. So we can see we have an option that is yes. This is the correct option for this question.